All right, so now that we've talked about speed and velocity, we're going to go one step further and talk about acceleration today. So, acceleration is when your velocity changes. Very rarely do objects just keep moving at the exact same speed in the exact same direction forever and ever. Eventually, they're going to speed up or slow down, or they're going to change direction. And that's what acceleration is. So velocity, as you know, says that or includes both the speed and a direction. So 45 miles per hour, that's a speed. 45 miles per hour north, that's a velocity, right? Acceleration is literally just when that changes. So when we speed up, when we slow down, or when we turn, change direction. So sometimes, most of the time, people think of acceleration as literally just speeding up. That's how we use it in everyday language. The accelerator in your car literally speeds the car up. But acceleration is not just that. It's important to know that it also includes any change in velocity. So speeding up counts, but so does slowing down because you've changed your speed. And so does turning. If you are walking and you walk around a corner and you've changed direction, even though you're still walking the same speed, you've accelerated because your velocity is different. You're moving in a different direction. This is literally everything I just said. So you can take a second if you want to pause it for a second and look at those pictures. But your speed can change, you can slow down, you can speed up, and your direction can change. That's all acceleration. Same thing here. A car driving around a curve at a constant speed. Even if it doesn't put on its brakes, it's still accelerating because its velocity changed. Its direction is changing. So 3 different slides, all to say the same thing, so I guess it's pretty important. So acceleration can be positive or negative acceleration. So positive, and they're exactly what they sound like. Positive acceleration is when an object speeds up. Negative acceleration is when its object is slowing down. So when I get in my car and I start driving, that's positive acceleration because I speed up. When I get where I'm going and I slow down and stop, that's negative acceleration because I'm slowing down. So we're going to skip those math problems. We're going to talk about those in class because math is hard to do over a video like this. So the last part of acceleration I want to talk about is free fall. So an object is in what we call free fall if it's accelerating because gravity is pulling on it. It's literally what it sounds like, free fall. It's not being pushed. There's no other force. So you're not running. A car is not driving. It's literally just something that's falling. The only thing making it move is gravity. That's it. So if you look at the picture here, you can see that. The only thing making this ball move after it's dropped is gravity, nothing else. So it's what we call free fall. Here's why free fall is so important. Gravity has a certain speed at which it pulls things. So when things fall, when things are in free fall, we don't have to measure them to know their speed. We already know their speed because gravity pulls on everything, no matter what it is. It pulls on it. It will increase their speed 9.8 meters per second every second. So let's go back and look at this picture over here. We drop the ball. After 1 second, it's going 9.8 meters per second. After 2 seconds, 9.8 plus 9.8 is 19.6 meters per second. So every second that it falls, it's going to gain 9.8 meters per second worth of speed because that is the speed that gravity pulls on things. So it can be a very lightweight feather or it can be a really heavy brick. It doesn't matter. It's going to fall at 9.8 meters per second every second. It's going to gain 9.8 meters per second worth of speed. So that's really all there is to acceleration. We're going to talk about the math part of it, how to calculate acceleration a little bit more in detail in class. But free fall, pretty important that you understand the pull of gravity here. So if you dive off a diving board, however many seconds it takes you to hit the pool, you're going to increase your speed by 9.8 meters per second every second. That's why if you jump from a low diving board, you go into the water pretty easily because you might only be going 9.8 meters per second. But if you jump really high and you've got a few seconds in the air, then every second you're going to be increasing your speed by 9.8 meters per second. So you're going to hit the water harder. That 9.8 is a number that you probably want to remember. Okay, so just like last time, if you could either fill out the notes, or if you don't want to fill out the notes, if you could send me a question, maybe it's a vocabulary word, again, you're confused about, maybe it's a picture that you saw on here that interests you that you have a question about. I just want to make sure that if there's anything at all that you want me to go into a little bit more detail about in class, go ahead and send me that question right now. One or the other, just to let me know that you watched the video, and we will talk about acceleration a little bit more tomorrow. Bye, guys.